Okay, I'm going to work through a couple examples on your proof practice worksheet involving parallel lines. So I'm going to start with number 2. And we're really moving into section 3.5 where we're using the converse theorems and postulate where we're trying to prove lines parallel, because if you notice the prove here is I have to prove that P is parallel to Q. So that's how this is different, but we're also going to use stuff that we used in the last section when we were in section 3.2, because our given information here is that L is parallel to M. So we have, and we looked at this situation in chapter 1, but not in the context of proof, where we had one set of lines parallel and the other set not. So I'm highlighting my parallel lines. We could put those arrows on to indicate that. And let's go ahead and write down our given information, and then we'll get started. So I noticed that it also tells me angle 1 is congruent to angle 11. This proof can get really complicated if you're not careful, because I told you at some point you were going to get too smart, and it's happening already. Because if you look at L being parallel to M, there should be at least, I'm going to just throw a number out there, probably 20 statements that you could say that are true based on what you observe in your picture and the given information that L is parallel to M. For instance, if I'm just looking at these angles up here, I have all kinds of angle pairs. I've got alternate interior angles congruent. I've got alternate exterior angles congruent, 4 and 6, 1 and 7. I have corresponding 1 and 5, 2 and 6. So I could start saying all of those, not to mention vertical angles congruent, linear pairs, and then of course I could go down here. So in order to get a little bit of a plan to our proof, I'm going to say let's focus on our given information. We're told something about 1 and 11. So let's pick one of those, and let's say something we know is true about one of them and a different angle. So I'm going to pick angle 1, because that's the first thing it says is angle 1 right here. And I'm going to say, okay, angle 1 is congruent to something else in that picture. And I'm not going to go to supplementary if I don't have to, because it's a lot easier just to link congruent statements together. So you might be seeing supplementary angles, and I'm seeing them too, but I'm going to choose to stick with congruent statements if I can. If I need to go to supplementary, I will. So angle 1 is congruent to something else in the picture. And I've said this before, I like to pick out corresponding angles. That just works for me. So I'm going to go ahead and say angle 1 is congruent to angle 5. Note there are about a million other things that I could have said that would have been true as well. If you said 1 was congruent to 7, that would work because those are alternate exterior angles, for example. And of course I need a reason to justify that. Angle 1 is congruent to angle 5 because if my lines are parallel, which they are, then corresponding angles are congruent, and that is my corresponding angles postulate. Or you could literally write out the statement that I just said, if lines are parallel, corresponding angles are congruent. So I now have 2 equations to work with, or 2 congruent statements. And I've also said this before, if you have at least 2 equations, you can do something with them. So before I even go to my picture and observe more things, I'm going to say, what can I do with what I have so far in my proof? Remember, I want to make this really clear to the reader of getting to the end, so I want to walk them through every step of my thinking. And I want to tell them, why did I just say angle 1 is congruent to angle 5? What was the point of that? Well, now I can make a new equation, or new congruent statement. If angle 1 is congruent to angle 11, and angle 1 is congruent to angle 5, what new congruent statement can I make? Hopefully you're thinking or seeing that angle 5 has to be congruent to angle 11 because they're both congruent to angle 1, therefore they're congruent to each other. Property I'm putting transitive property. If you were thinking substitution, I would take that as well. Okay, either one of those. Now, I still don't know if I'm getting to my proof, but so far I have a completely logical proof in what I've said so far. So 5 and 11, I'm now going to look at 5 and 11. So let's find them. 5's there and 11 is there. And I'm going to observe, well, those are alternate exterior angles. I know alternate exterior angles are congruent. Okay, now let's think about the proof because I don't want to do more work than I have to. I'm trying to prove that line P is parallel to line Q. And right now I'm looking at the right side of my picture. I don't think I can, maybe I can draw a, oh, I guess I'm getting an error. I'm looking at this side of my picture right here. And if I want to prove lines parallel, I have three converse theorems, one converse postulate, and then I have a couple others, that parallel transitivity theorem and my perpendicular transversal converse. But let's just start with what I have. Remember, I have alternate exterior angles are congruent to each other right here. If that's true, then can I conclude that lines are parallel? Absolutely, because that's what my converse theorems allow me to do. So I can make step 4, my proof, right here, that P is parallel to Q, and my reason is that if alternate exterior angles are congruent, then lines are parallel. Or in shorthand notation, alternate exterior angles theorem converse. If you don't have the word converse, it's wrong, because in reverse, that theorem says if lines are parallel, then angles are congruent. Okay, so we actually just used a forwards postulate theorem, and then we used a converse in addition to it. Before we go on to another proof, let's just take a minute and look at the difference of when I'm using those, because it can definitely be confusing. So if we go up here and we look at my first, the first time I used one of my angle pair postulate theorems, that was to say, let me grab a different color. That was to say that angles were congruent. So when I wrote my angles congruent statement, I used my corresponding angles postulate. And remember, that could be any one of them. It could be an alternate interior angle theorem, alternate exterior angle theorem. I just happen to be talking about corresponding angles. Notice that when I use the converse postulate or theorem, I'm not making a statement about angle relationships at all. I'm not saying angles are congruent or supplementary. I'm saying lines are parallel. The angle statement is above it. Those are my alternate exterior angles that led to lines being parallel so that I could then use my converse theorem. That's a little bit weird. And what I notice is that a lot of students like to say for step 3, their reason right here, they want to make that the alternate exterior angles theorem converse, or use alternate exterior angles theorem there, because they're noticing that they're alternate exterior angles, 5 and 11. But you have to make yourself think, how did you get that? And you didn't get it from the fact that they're alternate exterior angles, because you would have had to know lines parallel to say that. Hopefully I didn't confuse you too much, and I helped to sort out when you're going to use the converse versus the non-converse theorems. Let's go ahead and try another one.